So different scenarios are there. I showed you one of the scenarios. So this is the scenarios here. App, you have coffee shop and then bookstore. You want to block it. Another other one, you want to enable it. Here you are denying all non-white listed traffic in namespace. So this is something
Okay.
which you can also design. This is depends on the design. Deny all traffic from other namespace. Okay, except default one. So here foo is denied, bar is denied, and something like that. Here allow traffic from other namespace. Here you see you can. So visualization will be easy. So now look at the code here. You can practice it. So here kind is got to note network policy. This is for the default. Now for this network policy is applied on the watch pod, which is running on with label run backend. And there are two types of policy which we are adding in this sample code: ingress and egress. Ingress is all the pods which is allowed with run frontend, and egress with anything the pod which namespace selector, namespace labeled with an Cassandra. So this is the namespace selector. This is the pod selector. So egress allowed with a namespace, all the pods from this, and ingress is here. This is one more example, network policy. Port selector applied for this ingress. Port selector, this is something we tried also. So this is one more here. So here deny all incoming and outgoing traffic from all ports in namespace. So this is the best way to simple code. Now here allow Cassandra pod having incoming connection from the backend namespace. So the pod selected labeled with this ingress. This is the namespace labeled default. That means backend namespace. You can see that here.
So the backend namespace will have this label.
Yes.
Okay.
So network policy. So here now little bit here you see port label. This is where you can see port label. So far we were seeing at the pod level and namespace level all the traffic, not blocking the port, but this is the port. So deny all incoming and outgoing traffic from all port in a namespace default, but allow DNS traffic. So remember that every namespace has a DNS default and allow DNS traffic. This way you can do, for example, front end is a DNS name and curl back.
Curl you can do.
So backend also is here. Network policy, and here denying selector. So here port selector, all the ports you deny, except that here you are creating egress port number 53 for TCP and UDP.
But where is the exception? So this is a deny policy. So
Yeah.
deny all outgoing traffic. So egress we are saying. So where is that exception statement?
So here DNS 53 is a DNS, no? Port.
No, that is okay. So we are saying pod selector. We are saying everything, all the pods.
Everything is blocked, and all the traffic
Okay.
is allowed through the DNS server. Okay,
So,
I think you are not understanding. DNS server, core DNS default port is 53, no?
yeah, I know that. Okay.
Yeah. So
Okay.
all the traffic is forwarded through this you are using DNS, right? So all the traffic will be passed through the DNS server. Route 53 in AWS. 53. What is 53? This is not.
Yeah, I got that. That is the DNS port.
Outgoing. All the outgoing is allowed 53. That means you can talk to the
So,
DNS.
if you scroll up, if you go to the previous example, so where we have egress, maybe.
This is ingress.
Not ingress, egress. Maybe the
This is
previous
deny
one,
all.
above.
Hmm.
Okay, egress one is not there.
This is the
Yeah,
egress.
this one. Yeah. So the
So
egress
yeah,
one. So what this means is that whatever you have after egress, that is exception.
yeah. So egress
Okay.
2 means you are allowed to this namespace which is labeled with
So
an
this is
egress.
allowed.
Yeah.
Okay.
Outgoing.
Okay.
Egress is outgoing. No?
Yeah. Okay. Got it. Okay. Fine. So whatever we list, that is allowed.
Yeah.
Otherwise, everything is blocked. Okay.
Block by default is blocked.
Okay.
So this is
Default
the
is
DNS server you are allowing 53.
got
DNS
it.
server
Got it.
default port is 53.
Got it. Yeah. Okay.
Okay, so here deny all incoming and outgoing traffic from all ports in the namespace. So simply you say this is the one.
Okay. Got it.
This is allow front-end pod to communicate with back-end pods. So here you see that uh, egress to the back-end pod. That means all the traffic outgoing to the back-end pod.
If you scroll up 1 second on that one, so allow all front end pods to communicate to the backend. So this is not from and to.
No, it's a pod selector. No, here
Mhm.
it's the same namespace. It's the same namespace. You have
Okay.
a front-end pod also and back-end pod also. So here we are saying, hey, any pod which is having the labeled with this one, that is a front-end pod.
Okay.
And from here, it should be allowed to any pod which has a label with run backend.
Backend. Okay. Okay.
Here, one more example. So allow front-end pod to communicate with the backend pod, but here egress. This is a egress. This is also egress. So port selector. This is the policy type. Yeah, it's the same thing. It's copied 2 times. Yeah. Allow all going out. So here, this way you can specify. Okay, this is a consolidation of everything. So all going out traffic. So this is one program, another one, another one. So like that.
Okay.
So this is the examples of the network policy.
Yeah.
So this is the stuff. So you should follow this one very strictly. This flow, you can decide which one should talk, which one and all. So first create a diagram while implementing, and then create a network policies.
Got it.
Now
Got it. Yeah.
I'll give you, let's say, this URL for practicing it at least one scenarios, and
Sure.
after that we'll get into the next topic. So go ahead and try at least once, and after that we'll move on to the next one. After the network policies, you can also you should also secure the dashboard. So usually, how do we access the dashboard? So these are the 4 methods in which you can access the dashboard. You know that dashboard, the by default, it is accessible only inside the cluster. So if you want to access from outside, because it's a web-based application, so usually we use the Kube-proxy. Using the port forwarder command, you know that command, or kubelet proxy also is there, so you can use that. Or if you don't, you are using not using the Kube-proxy, then you are using the load balancer service. Load balancer service means that a service which you are having deployed, that is you are exposing with the load balancer.
Sure.
Let's say this is the additional cost also. So many people are doing the node port service. So node port also, and many people are doing authentication proxy. So these are the 4 methods in which you can access the dashboard. Most of this time we do that node port service. And so to make sure that when you do the node port service, uh, node port service, you have to control the network security groups and uh, OS level security groups also. So how do we access this dashboard? So these are the 2 ways with which you can access. One is a token, and another one is kubeconfig. So make sure that the dashboard should not be exposed to everyone. not for everyone, not from everyone. So these are the things you can do that. So let's say if you're using node boot service, primarily you will work with the firewall of the node and network node of a physical network nodes, which is a, you can say, cloud network also, and get it done. Now,
Can you please explain this node port and cluster IP once again? I studied it long back,
no
just
problem.
to brush up on that.
Yeah. So now see here, I'll give you the context. Actually, anyways, that is a part of one agenda as part of security. So here,
Okay.
first thing is, uh, uh, first thing is, uh, first thing is, let's say you deploy
Mm-hmm.
web and you deploy app also. When I say deploy, you understand that, I know that.
Yeah, yeah, yeah.
So 30 ports are there. Here
Mm-hmm.
also 30 ports are there. The
Yeah.
problem
Did
is,
you say both are web or web and app? App.
sorry, my bad, yeah. So app. So both are, multiple pods are there. The problem
Yeah.
is which of this pod from the front end will talk to which of the pods in the back end.
Mm.
Many challenges we have here. One thing is like, the pods are infidel. That means one pod, same pod, you will never get it. IP address will keep
Correct.
changing it. And
Correct.
many other challenges we have. So I'll not get into right now. So the
Right.
question is very simple: how to load balance? Because load
Correct.
balancing is a simple solutions for this. How to load
Mm.
balance a pod? I'm talking to pod, okay?
Yeah.
So how to load balance? So simple answer is
Service.
service. Now I'll put in a little bit more context here. Load balance, primarily we see two types of it. Load balancers, primarily we see two types of it, which are the one is like a network load balancer, right? And another one
Application
is
load balancer.
application load balancer. So now, uh, what I have hard coded my mind, whenever I say network load balancer, that means I correlate service. Whenever someone say, hey, application load balancer, then I correlate NLS. Okay.
Hmm.
So this is the way I design my mind. So because in
Okay.
Ingress we can set a rule, app load balancer we can also set a rules. Service, which is works on the pod network, IP address and port number, TCP. Network load balancer also work on the same way, L3
Hmm.
and stuff like that.
Hmm.
So now the question was how to load balance the pod. Answer is service. Now here we have types of service. Okay, I'll explain you. Just give me a few minutes. Types of service. Now, which are the types of service? There's one is cluster IP. See, break this word. Clustered IP. That means
Yeah.
this service will get a IP address from the cluster.
Mm-hmm.
There are three networking again networks in Kubernetes cluster. So there are three networks are available in the Kubernetes cluster. Three network. Okay, mind it.
Mm-hmm.
One is pod network. Okay.
Yeah.
Second one is node
Host
network.
node network
Node,
or host
yeah,
network.
that's the
Yeah.
same
Yeah.
thing you said. And third one is cluster network.
Cluster. Yeah.
Okay. So now cluster network and pod network powered by CNI, and policy is the one which you have. This node network powered by cloud. Okay. So when I
Cloud
say,
or whatever is the physical network.
yeah, that
Got it.
nowadays anyways we are not running actually. So
Okay.
yeah, so CNI, here this CNI is powered by proxy, and then one more thing, policy. It can be Calico here also. Correct now? So
Hmm.
IP table, route table, all this thing is been managed by that one. So I'll not get into that. Come to the point here. So clustered
Mm-hmm.
IP means this service will get the IP address from the cluster network.
Yeah.
Got
Yeah.
it?
Okay.
So
Okay.
that is a things. Now there's a CIDR set to default CIDR, while init no QADM init. You can
Mm-hmm.
influence actually all these things you can do.
Oh. Okay. Okay.
So that's a clustered IP. Second one is which we call it a node port. Just break the chain.
Sorry to interrupt you, but the cluster IP, again, there is no port associated with the cluster IP, right? It's just the IP.
Yes, just IP address.
Okay.
See, remember that concept, very simple concept. Port is never allocated to the pod level or service level. Port is always located at the container level, and then forwarding happen at the service level port. Understand that? Port is the internal to the system, means application runtime.
Kubernetes.
No. Port, okay, I'll
Kubernetes.
put it in this way. Uh,
Mm.
I'll put it in this way. Forget about the Kubernetes. I can run Apache on some port, 80 port. Let's say network is not there. So can I not run 80 port? I can run it. So port is internal to the system.
Right.
Okay, it is not required the networking for that. But for that, to access from outside, you need IP address, then port number where the UDP transfer happens. Correct now? Yeah. So here it is. So coming back to the point here, service, types of service. Clustered IP means this service will get a clustered IP. Node port, I'll explain in some time. One is we have a load balancer. Okay, load balancer. And the third one, a fourth one, which has come recently from last 1.5 years, I'm seeing external name. Okay, so these three I'm talking about right now. This also I can talk about, but for that you require a little bit of DNS discussions.
Okay.
Okay, so now let's understand this. So MS Paint, understand in a simple way. This is your cluster. I repeat, I said cluster. And this is the one worker. There's another worker. Now here I am having one front end pod running here and here. Now second one I'm having back what I did. Just a second, hold on. I have a one front end pod here and one front end pod here. Why in the two node? Because you know that Kubernetes believe all machines is a part of the cluster, so it can deploy anywhere. Why color is changing? I'm not sure. It's correct. So and then after that I'm so this is the front end pod. After that, I'll have a backend pod. This is the backend pod. Okay. Now, theoretically speaking, remember that theoretically speaking, you have a network where. So this is a node network. Agree? This is the pod network. Agree?
Yeah.
This is the pod network. Pod network is been powered by pod network. Node network is powered by node network, like a cloud. Now, this is the front end. Okay, and this is the front end, and this is the back end. This is the back end. Now, so front end need to talk to back end. Forget about rest of the people. Only front end need to talk to the back end. So now front end is confused. What back end? Because this is IP address, this is also IP address, and in real you have a 500 ports. So and that each port is getting rotated every time, changed every time, keep coming, going, and this, that, and all stuff like that. So now what we need one load balancer, means service balancing the backend. Agree with me?
Yeah.
So here this is the row. This is the row. Now so front end, now this is also having IP address. Okay. So now service also having IP address, which is from the clustered port, clustered range, cluster network. Okay. So now service. So now what will happen? The back end, a front end will talk to this guy, and this front end also will talk to this guy. Agree?
Yeah.
So what has happened? The one problem is solved. The problem is internal load balancing. That means one service to another service. Like that, you have a load balancing solved. Correct now?
Yeah.
Now there is a problem here. So now let's say there is another guy which is sitting inside another guy, means it can be some other applications, microservices. Is a microservices. So these microservices need to connect to the front end. So for that we need one. You know what? For that we need one more service. This time from the front end. So we'll create one more service. This will load balance this front end and this front end. So now this guy can talk to this service because this has IP address also, which is a part of the cluster. Correct now?
Yeah. Yeah.
So far clear, right?
Yeah.
Now the problem, there's one more problem which is arising. The problem is from the outside. Like how this, because this guy is sitting somewhere outside of the cluster. So how can he access this service? Getting my
Mhm.
points?
Yeah. Yeah.
So this is not allowed. This is not allowed.
Mhm.
Okay. So what do we do in this case? What we do in this case?
So we have to expose this service somehow.
So here, if you look at this, I'll show you one command for that. Okay. So
kubectl expose.
yeah, just a I'm getting some call.
Okay.
Yeah. So here, kubectl. I was showing you something, right? What was showing? I missed the context.
That service, exposing the service.
So here, I want to show you here. Are you comfortable with this command, port forwarding?
I haven't used it, but it's okay. I can try to understand.
So do you know the Docker-P option, right?
Uh-huh.
So if you use -p with a Docker, then it will make the container accessible on the node port, right? The host port,
Yeah,
right? So
correct.
here, same way, port forward is one command which will expose this pod, this pod, this pod, this
Mhm.
pod, this pod, this pod to the node port.
Node port.
Okay. So now I'm not trying to tell you I'm exposing the pod at the node. I'm not saying. Please look at this.
Mhm.
Here, look at this, only read this. So what it will
Yeah.
happen, this pod, it will expose port forward at the node port at the 6000 port number. The pod port number is 5000. Okay, understood?
And it will expose at 6000.
Yeah, sorry, you look at this one. This is more easy. I think this is little.
This is the correct one. That is the other one.
No, yeah, it's forwarding and to from blah blah blah. So this is a more clearer. See, port forwarded. This one 888 is a IP address, a port number for the pod, and 5000 is a port number of node. Okay,
Got
are
it.
you comfortable with this?
Yeah, yeah, yeah. Okay.
Yeah. So node. This is the node. Remember, 5000 is a node. Okay, there's a node. Now this not only pod we can forward, we can also do the forward for
Service.
services. Okay, so here your service port number is 8443,
8443.
and here it can be some HTTPS, whatever it is. Okay, so this is the same thing here if you read a little bit more about it. So
Okay.
right now, what I want, see, this guy cannot access this service directly. Why? Because this service is with the clustered IP, clustered network, and this guy is somewhere outside of the cluster. This is not on a clustered network. So what will do? Now, theoretically, if that if the network of the node, please hear me out clearly, network of the node is open up, then can he not allow this and can he not access this IP address of the node?
Yeah, we can.
It can, right? Because just now you are connecting no IP address of the port and node.
Node. Yeah,
I
yeah.
gave you two IP address. So yeah, it is possible. But the problem here is he can talk to this IP address of the node, but where to forward that traffic? That is not there. So what will happen? This
What do you, sorry, where to forward that traffic?
see,
That is not defined. I got you. Okay,
yeah,
okay.
yeah. So I can reach to the node port, but from here forwarding will not happen anywhere. So what we do actually, theoretically, I'm just telling you manually, this service what you have, no, this service port forward a certain port of the node here and here. Okay, that means if I hit to that node port on that port number, it will read to this service. This service will take me to the one of the front end pod. From the one of the front end pod to the back end pod, a back end service, and back end service to the back end pod. One of this. Are you understanding this?
Yeah.
Are you understanding this flow, manual flow?
Yeah, I got it.
So this to work, you need to service to port forward. That's the reason I showed you this command. Okay, manually you can port forward. Understood?
Got it. So when you do this, first you need to have the service, right?
You need to have a
And
service, then only you
then,
can forward. No, here you have a
Mhm.
service, then only you can forward. Where is it? Here.
Mhm. Yeah, but in this case, I mean, pod also you can forward, but if you have a single pod, but if you have multiple pods, then you need a
It's
service and
correct.
then you
Then your
forward it.
service. Got it?
Okay, okay.
Okay. So now come back to the topic here. What is
Mhm.
a clustered IP? So clustered IP will create a load balancer. I'm putting in a simple word. Okay. Clustered
Mhm.
IP will create load balancer means service. Okay.
Yeah,
Okay. Service. Load balancer. Create a load balancer service. Balancing pod. Make sense?
fine. Yeah.
Okay. And this clustered IP, IP of service would be accessible.
From outside.
No. Inside, no, it's a clustered IP.
Uh, but then
It's a
how
cluster.
does someone from outside access
I'll
it?
discuss that one. I'm discussing. So
Okay.
this one you understand, no? This service I'm talking about, and this service.
Okay.
Okay.
Yeah.
So this IP address of service will be accessible inside a cluster. Now, what is happening in the node port? When you select the type equal to node port, what will happen? It will do this clustered IP and plus service would get forwarded at each node of
Node.
the cluster. That means two things it will do. If you create a service type node port, then what will happen? It will create a clustered IP port, a clustered IP
Mhm.
service, okay,
Mhm.
which will be accessible inside a cluster. It will do the same thing, but also this it will save your time doing this one also.
Mhm.
Got it?
Okay. Yeah.
Earlier you are doing through port forwarding, no? You don't have to do that
Mhm.
this way. You don't have to do that. So this, if you
Okay.
select the type node port, that means the service will be accessible in this node. So
Mhm.
let me do one thing. kubectl kubectl get deploy. So I have deploy no. So run -h. This one deployment I'm doing. Okay.
Mhm.
Oh, sorry. Uh,
Spelling mistake.
yeah. Okay, so I'm deploying here. Okay. Get
Mhm.
deploy. Now you know I'm doing what? Creating a service. So kubectl expose deploy. All this
Right.
command you are comfortable, right?
Yeah.
Yeah, wonderful. So now here, I'm not selecting that anything type and all. Why?
Type cluster IP or
Huh.
node port. You're
So
not
this is
selecting.
default actually. This is
Mhm.
default. If you don't specify, and what happens? There's a TCP actually I have to set. I forgot that TCP. Mhm.
My
My
dev.
dev. Okay, so you see that here. Here my service port is 80 port. I made a wrong thing. Let me delete this. Okay, hold on. Get SVC, delete SVC, and my dev. Deleted. Now 80. So my container is running on the 80 port. Nginx runs on 80 port. Okay, and service port number is 80. And date this. Now you see that here. Here you see this is my service. Now what is the type? Clustered IP. This IP address on which I can ping or
Access
curl,
it.
whatever you can do that. Ping is not allowed actually. So curl you can do easily. And see it.
Yeah. Yeah.
Okay. So now what is happening? I got this. This I can access inside this IP address I can access inside on this particular port, but cannot access from outside because it's a
Outside.
clustered IP, right? So what I
Correct.
said, this service, what you see, my dep need to be exposed at the node port. Okay. So what we do in this case? So read this here. When you use the type clustered IP, create a service clustered IP also here. Service with the clustered IP and also exposing happen. So let me show you that. Let me show you here. Deploy name np node port. I am naming name and type is equal to. This is a case sensitive
Node port.
Okay, so earlier clustered IP was default and node port. So see the difference. This is the one. So here you got a clustered IP also, and this is the service port number which is accessible inside the cluster. This port number which you can see is a
On the
node port number. Node
So this target port, the port 80 which you have given above, that is ignored, right?
No, this is container port number. Pod.
No, the other hyphen port 80, the first
This one is a service. This is a service. This is the pod. And this is the node port which is here.
Oh, okay.
I will give you one statement. Node port always start with 31 or 32. Always remember. And it's a five digit.
Correct. Yeah.
Okay.
Hello everyone, if you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc. Kindly become our channel members by clicking on the joining button. You would have access to 100s of playlists and 1000s of videos lifetime access with this membership. Enjoy.
Thanks for watching. Want to study further? Join our training programs today.